Hey, Ms. Awad, we're going to finish up the rest of sedimentary rock idea
Excellent.
here. All right, so we're going to talk about two different types of sedimentary rocks. Before we talked about detrital or clastic, same thing.
Yeah.
Now we're going to start talking about the biochemical or bioclastic and the mineral, the chemical ones,
Okay.
the crystalline ones.
Good.
So we'll start with bioclastic. Now when I think bio, I think biology, life.
Yeah.
So it's got to be made from once living things.
Okay.
Okay, so the first one I see on here, I see that they're made of plant fragments. Okay, so now I'm looking for something that looks like a plant fragment. If I take a look at this, you guys can see like sticks and twigs, and these are like basically old pieces of plant life or plant material that have been kind of consolidated. You can kind of see them squished in little lines right here. And you can see that at one point this was all just squished together and formed this rock here. And if I look across on my table here, if I move all this stuff, I just fell onto it, I have brown porous rock with visible plant fragments easily broken apart. It did all those. So it's a rock we call peat.
Okay. Great. Let's get peat off the paper
Oh my
here.
gosh,
there
peat's
we
all
go.
over the place. Alright, so then if we keep moving down, we've got two more types that end up being products of peat. So if I have a little bit more pressure, a little bit more time, I get a thing called lignite and bituminous coal. So for both of them, I start getting darker colors. Okay, so I start getting a black, I start getting layers, I start seeing brittle rocks. You guys can see with this one it breaks real easy. And now I'm getting brittle coal all over the place.
So in this one you can't see any more of the fragments of the plant like you could in the peat.
And I just noticed that it's really dark. So that's usually a sign of organics, is that really dark color. So this is going to be one of our bituminous coals here. Okay. So basically that's what peat is later on. So I take this peat, I squish it down a little bit more, I process it a little bit, and it turns to this bituminous coal.
Okay.
Alright. This one isn't the lignite, is it?
I don't think we have any lignite
I think
right
these
now.
are both just the
Yep.
bituminous coals.
Yep.
Good. Okay, so let me clean up my mess that I made over here.
Okay. Goodbye peat.
See
Goodbye
ya,
coal. All right. So now we're going to move into a different kind of biochemical sedimentary rock, and we're going to move into the kinds of biochemical sedimentary rocks that form in places like a marine beach. So you'll look at these and you think, wow, that looks like little grains of oatmeal all stuck together. Well, those little white grains of oatmeal all stuck together are fragments of shells. So if you think about a coral reef environment or a near shore environment where you've got clams and oysters and snails, all those kinds of shelled organisms living in the sand, when they die, their shells wash around in the waves, they get broken up, and they get stuck together, and they form this very, very young kind of sedimentary rock. So let's take a look at our chart. And we have the description here, mostly gravel-sized shells and shell or coral fragments. And this is a rock that's called coquina.
Okay.
Coquina. So this is very typical of the way coquina looks. Now, if this rock hangs around a little while, you get it a little bit more well cemented, under a little bit more pressure, and the shells in it are more fossilized shells. Then you're going to get, well, let's go to the big piece right here. This is a better one, so let's just go straight to this one. You're going to get a situation where you have pieces of fossil shells. You can see the darker gray shells here, and they're being held together by a very clayey, smooth kind of mud. So again, you've got shells that have been washed around in a near-shore marine environment, and these are older shells than these are. So you have an older kind of limestone than you have here. So let's look at the description in the book. We've got mostly sand-sized shell fragments, may contain some larger whole fossil shells, and that's what we're seeing in the bigger piece. And this is called a calcarenite, or a fossiliferous limestone.
Okay.
Okay?
Well,
So those are two of those.
I think the next one I can tackle.
Yay.
So this one's chalk. Now it's really cool because you see a lot of really fine, well, you don't see a lot of really fine-grained particles. And so if I look at my fingers, I can actually draw on my fingers. These are all those fine-grained particles. It feels real smooth, real kind of slick, and those are all the little particles breaking down. Now if I take a look at the description, it says silty, earthy rock comprised of the microscopic shells of calcareous phytoplankton. So you're telling me that this once used to be alive?
Yes.
What?
Very, very small little animals that live in the water column.
Uh-huh.
And that's what's forming that chalk deposit. So in the last video when we were talking about marine deep sea environments, we were talking about the little shells raining down, looking like snow deep in the water. And over millions of years, they pile up, and that's what you get.
And so
you get
it's
the
just
white cliffs of Dover.
Oh my gosh, so entire cliff face is made of chalk.
Yes.
That's incredible. And this is all just like the shells and skeletons of these little, what did they call
Phytoplankton.
it? Phytoplankton. Oh my gosh, that's really cool.
Yeah.
Okay.
All right.
So that's actually most of what we'll see with the biologically created, ones that are made from once living organisms. So now we're moving more towards the chemical rocks.
Okay.
Okay. So some of the first ones that we see, actually we don't have, yeah, we got the dolostone. So if we take a look at dolostone, what we see here is that it's actually a microcrystalline dolostone. So it's really small. I can't really see any crystal, or I can't see like grain sizes. I'm looking at really small crystals. If I busted out the microscope, I'd see really, really fine crystals that form. And I look at the description, oh, we should have grabbed some acid, is that it effervesces in dilute hydrochloric acid if powdered.
Okay.
So if we took some acid on here, powdered up the rock a little bit, it would start to fizz and effervesce.
Okay.
Okay. What can you tell us about how these ones form? They're kind of similar, right?
Yeah, so the dolostone is going to be a rock that's going to form as a precipitate, again, out of seawater. So calcium, magnesium carbonate precipitating out of seawater, piling up on the bottom of the ocean, again, having the water pressed out of it over time, leaving behind this dolostone.
Okay.
So this is a precipitate, a chemical precipitate, which is different from the last two types that we have to talk about. And that would be the rock salt. In this case, we've got some pieces of halite that some of you may have actually tasted while we were doing the mineral lab.
And I got to do it right now, just
And-
to be sure.
okay,
I mean, this
check.
is
Check.
halite.
Make the face.
It's halite, yeah.
Okay. Now, halite is not a precipitate. Instead, halite is an evaporate,
Okay.
right? So you take the salt water and you evaporate the water off, leaving behind
Just the salt.
just the salt.
And if it goes slow enough, you get these nice big crystals like
Absolutely.
this. Okay, so that's a type of sedimentary rock that forms chemically. You just remove the water and you're left with all the salt that's left. Okay.
Okay, and our last one, which is the rock gypsum, this is a variety that's called selenite. And you can see that it has kind of these really long crystals here, also an evaporite.
Okay. So this used to be like in liquid form and then you evaporated off all the water.
Right.
Okay.
All right, so similar formation here.
And so for environments for these, again, we're talking some sort of salty water. So like maybe transitional or something like that, close to the coastline. Evaporate the water away, you're left with salt. Cool. Is that easy?
It's that easy.
Wow, that is that easy.
Okay.
Cool.
Thanks, Mr. Baldwin.
Thanks for helping.
All right.
You gotta
Check
quit
out
it
the
after you.
check out the quiz on your class webpage, and we'll see you in class tomorrow.
See you guys tomorrow.
Bye, guys.